Hi, in this video, you will learn how to use Hibernate framework to implement a many-to-many mapping with extra columns in the join table, which uses separate primary key. I am Nam Haming from codejava.net. Let's consider a basic many-to-many relationship between two tables, groups and users. A group can contain one or more users, and a user can belong to one or more groups, and the join table is users underscore groups here. And in this basic many-to-many relationship, the join table has only foreign keys that refer to the primary keys of the two tables. You see user underscore id column here is foreign key refers to the primary key user underscore id in the users table, and group underscore id column here refers to the primary key group underscore id of the groups table. And this is an advanced many-to-many relationship between two tables, products and orders. An order can contain one or more products, and a product can be in one or more orders. And the join table is order underscore details here, where you see besides the front keys order underscore id, product underscore id, and the join table can have extra columns, quantity and subtotal here, and a separate primary key order underscore detail underscore id here. So this advanced many-to-many relationship allows us to use extra columns in the join table. So throughout this video, you will learn how to use Hibernate framework with JPA annotation to map a many-to-many relationship with the join table having extra columns and separate primary key. I will guide you to develop a Java project using the following technologies: Hibernate framework called JPA annotations, MySQL JDBC driver, and make sure that you have the following software programs installed on the computer: Java Development Kit JDK, MySQL database, both server and workbench tool, and Eclipse IDE. Now let's create a new Java project in Eclipse IDE. Go to menu file, new Maven project. Check this option to create a simple project. Next, group ID is net.codejava. Artifact ID is Hibernate Many to Many demo. Name Hibernate Many to Many demo. Description: Hibernate Many to Many mapping with extra columns in a join table with separate primary key. Okay, click finish, and we got Java Maven project created here. Change Java version to Java 1.8. And open the Maven project file pom.xml, and we need to specify dependencies for Hibernate framework core and MySQL JDBC driver. Dependencies. The first dependency is for Hibernate framework core. Group ID is org.hibernate. and artifact ID is Hibernate dash core, and version is 5.4.4. Final, which is the latest version as of now. At the time I'm writing this code. And the second dependency is for my SQL JDBC driver. Root ID is MySQL. Artifact ID is MySQL dash connector dash Java, and the version is 5.1.46, which is compatible to the version of MySQL database server running on my computer. Okay, save. And you see Maven automatically downloads all the required jar files. Hamlet, sorry. Okay, and you see here we have jar files for Hibernate core and MySQL JDBC driver here. And next we need to create a Hibernate configuration file under the resources directory here, new as a XML file. Next, and the Hibernate configuration file is hibernate.cfg.xml. Finish. And the root element of this file is Hibernate dash configuration, and then session factory, and then we specify properties for the database connection information. Property name equal connection dot URL. The first property is JDBC URL, which is JDBC colon MySQL colon // and the host name is localhost because I'm running my SQL database on the same machine, and the default port number of MySQL is 3306, and the database schema is test. And you can see this is my SQL Workbench program, and I have a database schema test here, and you see at the moment we have no tables at all. And the second property is for the username to access the database. I'm using the username root, and then the property for password, and the next property we need to specify the database and dialect. For MySQL we use the class org.hibernate.dialect.mysql 5 inodb dialect. You see, and we also specify the property to let Hibernate print and format the SQL statements in the console view. Property name equal Hibernate dot show underscore SQL value true. And the second property is Hibernate dot format underscore SQL true. So this is a Hibernate configuration file. Next, we are going to code Java entity classes to map with these tables in the database and products, orders, and order underscore details. So we will be creating the corresponding entity classes, product, order detail, and order, and to implement many-to-many relationship between the product and order with extra columns, quantity and subtotal in the join table. We need to have a setup order details in the product entity class with the one-to-many annotation, and in the order we have a collection of order detail as well using one-to-many annotation as well. And in the order detail, the join table, for the join table we have a separate primary key and reference to product and order using many-to-one and annotation, and this is the extra columns. So to implement many-to-many relationship with extra columns and separate primary key of the join table, we break down a many-to-many relationship into two one-to-many relationships. The first one-to-many relationship is between the product and order detail, and the second one-to-many relationship is between order and order detail. Come back to Eclipse IDE. Now we create entity classes, new class. Package is net.code Java. The first entity class is product. Finish. And under this package we also create the order entity class and order detail. Order detail. Now let's code the product entity class. This product entity class has fields ID, private integer ID, and name of the product and price. And we generate vectors and setters for this entity class. Source, generate vector and setters. Set all, generate, and also generate constructor. Source, generate constructor using fields and take ID. Okay. And we also need a no argument constructor. Source, generate constructor from superclass, generate, and format the code. And to map this entity class with the product table in the database, we use the BA annotation entity and table annotation. Specify the table name is products, and the ID field maps to the primary column in the products table, so we use the ID annotation, and we specify the column name in the database is product underscore ID. And because this is a primary key, we use a generated value annotation to specify that the values of this field are automatically generated and incremented by MySQL database. So we specify the strategy is generation type identity. And for the field name, it has same name with the name column in the database. So we just specify the size of the data in the database is, for example, um, 48 characters maximum. And to implement one-to-many relationship between product and order detail, we need to have a set of order detail in this entity class. Where we set order details equal new asset, and we use one-to-many annotation here. One-to-many annotation and mapped by the property product in the order detail entity class. And now in the order detail class here, we need to have a reference to the product here. And in the order detail entity class, we have the fields ID, private integer ID, and reference is to product and order. And the HR columns, the HR field is quantity and subtotal. And now we generate constructors and setters and getters for this entity class order detail. Source generate getter and setters. Select all and generate constructors. Source generate constructor using fields generate, and we need no argument and constructor. Okay. And let's go to the order class. In the order class, we have the fields order ID, customer name, and the total. Private integer ID, customer, and total amount of the order. And because we are going to invent one-to-many relationship between order and order details, so we need to have a set collection of order details in the order entity class here. Private set order details equal new has set, and now we generate getter and setter methods. Getter and set here. Select all. Generate and generate constructor for this entity class. constructor using fields. Okay, and we need to have an no argument constructor. Okay, and we use ZPA annotation to annotate this entity class entity and the table annotation to specify the table name in the database, which is others. And for the field ID, we use the ID annotation and specify the column name is order underscore ID and then value, which strategy is generation type identity. And for the field customer, we just specify the length of the data type in the column is 64, for example. And for the correction set order detail, we use the one-to-many annotation. One-to-many annotation mapped by the property order in the order detail class. We have the order here. And for the order entity, we specify the cascade type for the set order detail here. So when an order object is persisted as a belonging order detail will be persisted as well. Cascade type or now let's use the ZPA annotation to annotate this order detail entity class to map with the row table in the database. We use the entity annotation and table name is order underscore details, and this is a separate primary key of the row table ID. Sorry, ID and column name is order underscore detail underscore ID and generated value strategy generation type identity. And for the reference to product, we use the many to one annotation. And with the column is product underscore ID. And we do the same for the other object reference, many to one. And the column is order underscore ID. For the extract columns, extract field, quantity, and subtotal, we use the same name with the database, so we don't have to specify any annotation for this fields, quantity, and subtotal. So that's it for the annotation mapping for the entity classes. And we need to specify the entity classes in the Hibernate configuration file here. mapping class equal the fully qualified name of the entity class net.codejava.product, and the same for other entity class and other detail class. And in this Hibernate project, we will be using forward engineering to generate tables from entity classes. So we need to specify a property to tell Hibernate to automatically create the tables. The property name is hibernate.hbm to ddr.auto, and the value is create to let Hibernate create the tables. And next we need to write a test program. The name is Hibernate Many to Many demo. Check this option to create the main method, and here we go. And we need to build a Hibernate session. Standard service registry equal new standard service registry builder. Configure and build, and we create a session factory from the registry session factory equal new metadata sources. Registry and build metadata and build session factory, and then we can open a session from the session factory. Session equal factory open. Sorry, the name of the variable is factory open session. And for the first time we need Hibernate to create a table, so we just open the session and close it. Session close and factory close. And now let's run this program. You see in the database schema test here, we have no tables at all. Refresh, no table at all. And now let's run this program. And you see Hibernate print some SQL statement. First, it tries to alter the table, drop the foreign key, but the table doesn't exist, so it throws exception. So this here normal. And then you can see Hibernate create the table, all the details here with separate primary key. Here you see all the underscore detail, underscore ID, and the extra columns, quantity and subtotal in the join table here. And then create the table orders and table products. And it alters the table to add the foreign key. Two foreign keys in the join table or the underscore detail, referring order ID and product ID. And let's refresh the database. Refresh all, and you see three tables were created by Hibernate here. Products, and you can see the columns: product underscore ID, name, price, and the next table is orders columns, order underscore ID, customer, total, and the joy table, order underscore details here with separate primary key here, order underscore detail underscore ID, extra columns, quantity, and subtotal here, and these are the front keys to tables, orders, and products. Now let's right click on the table, and you can see there are two front keys here. You see on the table orders, and you can see the column customer has data type varchar 64 here. You see 64 is the maximum length we specify in the entity class here. You see, let me show you order, and you can see 64 here. So far so good, right? And for the product table, on the table, and you can see the column name has data type varchar 48. You see 48 is the maximum length for the product name we specify here. You see. Now let's select rows from this table, and you see all tables are empty. Order underscore detail, the joy table empty. You see, and the other tables empty as well. Products table empty as well. Now let's update the demo program to proceed some entity objects to the database. So we begin the transaction session. Begin transaction. And create two product objects. Product 1 equal new product. Name is iPhone 10. Price is 100, and the second product is Kindle reader. Price is 50, and then we create an order object. Order equal new order. We need to update its constructor. No ID, just customer name and the total amount. Here, the customer name is Ravi Kumar. Total amount is, for example, 200, and then we need to create two order detail objects. Order detail 1. In this order detail contains the first product 1, and the order and quantity is 1, and the subtotal is 100, and the second order detail object, order detail 2 that contains product 2 and the quantity is 2. Subtotal is 100, so the total of the order is 200, and we need to add order detail to the main order. In the order class, we write a method to add order detail to the collection order details. Yeah. Public void add order detail, order detail, order detail. This order details, add order detail. Okay. Here we add order detail to the main order. Order detail 1 and order detail 2. And finally, we save the main order to the session. Main order, not order detail. And note that in the order entity class, we specify the cascade time is all here. Then the belonging order details will be proceeded as well. Now let's run this program. And you see in the database, all tables are empty. Run this program again. And you see Hamlet prints the SQL statement to insert into others, underscore details, and insert into, let me see, it doesn't insert into a product table. Let's see. Let's check the database. Refresh the product. Oh, well, the product table is empty. Ravikuma 1 row in the order table. And order details. Product ID is no. So we have something wrong. We need to change the value of this property to none. So Hamlet won't create the table each time we run the demo program. And in the order detail here, with reference to product and order here, we need to specify the cascade time here. Sorry, cascade in the one-to-many annotation. Cascade time equal cascade time. Oh, now run the program again. Back to use grid, so it will interrupt the existing tables and data. Now run the demo program again. Now this time it works properly. I think it inserts rows into order tables, products table, and order details table. You see here. Now let's check the database in the products table. You see we have 2 products with ID 1, 2 here, Kindle Reader and iPhone. And let's refresh orders table, and we have on order from the customer Ravi Kumar order ID 1, and in the joy table order details here refresh. You see we have two order details. The first one refer to order, both refer to order ID 1, and the first refer to product 1, the second refers to product 2, quantity 1 2, you see here. So that means our demo program runs perfectly for many-to-many relationship with extra columns in the join table. Now let's update the program to insert the second order for the existing products. We need to change this property to none, and in the demo program we specify existing product, so we need to specify the product ID. So we need to generate another constructor that takes the product ID, name, and price. Generate, yeah. Okay. In the database, we have two existing products, ID 1 and ID 2. Yeah. ID 1 is Kindle Reader, and ID 2 is iPhone 10. Now we proceed the second order from the customer Nam Minh, and this time the total is about 400. And the order detail, the first order detail for the product 1, quantity is 2, and so the subtotal is 2. The second order detail for product 2, the subtotal is 300. So the quantity is 6 items, and the total in the order is 500. Now let's run this program. You see now Hamlet doesn't create the tables anymore, because we use the attribute value none here, and in the console view you see I made prints SQL statement to insert into orders order underscore details, and no products because we use existing products. And let's check the database, refresh the product table, still have 2 products, and in the order you can see the second order ID 2 here from customer Nam Ha Minh, and total amount is 500. And let's refresh the order details, and you see we have here 2 new rows here for the order ID 2, quantity 6 and 2, and subtotal 300 and 200 for the product ID 1 and 2. Very good, right? Well, so far you have learned how to use Hamlet with JPA annotation to implement a many-to-many mapping with extra columns in the join table, and the join table also has separate primary key, as you can see here. The join table we have separate primary key and with extra columns, and to implement structure many-to-many relationship, the breakdown is to into 2 one-to-many relationships, and we use forward engineering to create the tables from the entity classes. So I hope you will find this video tutorial helpful. Please like, comment, and share. Thank you.